So good morning and welcome everyone. My name is Annie Nash. I work on the Google for Education team, and I actually live and work in Chicago, so local to Illinois, and support districts across the state. And I'm joined here with my colleagues Karen and Nicki Anselmo today to talk about computer science as part of IDEA's Wednesday webinar series. So Google will be here pretty much every Wednesday throughout the month of September, with one exception. I think we're Thursday the 15th next week. So without further ado, I'm going to pass it over to Nicki, who is our expert in this area, to share more about expanding access to computer science.
Awesome. Thanks, Anne. And really appreciate all of y'all for being here. I think it's incredible that in addition to getting your school years launched and ready and off the ground, you're taking the additional initiative to think more about computer science participation, being part of this community together, and helping ideate and share best practices with each other. I think when we think about computer science, it's such a transformative skill. And yet, for a lot of schools, teachers, and districts, it kind of becomes a nice to have instead of a need to have, which again just means that teachers need to put in that extra effort. And I really applaud all of y'all for being here and being willing to learn a little bit more and share some of your experiences with implementing computer science. So a little bit more about myself. I'm a learning experience designer here at Google, specifically with the programs and products that reach our kindergarten all the way through post-secondary computer science students. So really thinking about who historically has been engaged and involved in computer science, and how can we make sure that the creators of technology are reflective of the communities that we work within, and are reflective of society more broadly. And so before I was at Google, I was actually a software engineer myself. So like Anne, I'm actually live in Chicago, so I was a software engineer in Chicago. I then was a middle school math and science teacher in New Orleans before I came back to Chicago, where I was an 8th grade computer science teacher and also started a 4th grade robotics club. Since being at Google, I've designed programs for high school students and for college students, and I've continued to stay involved in the elementary space as well. So hopefully some of that experience will be helpful as y'all think about how you might be navigating implementing computer science programs for your schools and districts. So during our time together, we'll spend time not only learning, but more importantly, discussing the following 4 themes. So why computer science? Y'all are obviously here for a reason. I'm so excited to kind of understand what it is about computer science that makes you excited. The second piece we'll talk about is super briefly what some of the trends are in terms of computer science access and equity here in our state. We'll talk a little bit more about implementing computer science at your school, using some Google products, using some other programs and platforms that I recommend, and then importantly, spend some time discussing how do we create inclusive learning spaces to make sure that the computer science ecosystem truly is reflective and representative and includes all of the incredible talent that we know exists across our state. So that's our time together. If you are able to type in chat today, we are going to have a few discussion prompts, because I think the value of a community like this is not really me talking at y'all, but more importantly, us collaborating together and figuring out what's working at your schools and districts, what's not working, and how can we maybe brainstorm so that you leave today's session with something that you can take back and implement. So in that vein, before I talk about why I think computer science is so important, I'm really curious what your take is on it. So in the chat, go ahead and type, why are you here today? It's a busy part of the year, a busy week, but what about CS makes you excited and interested? Thank you, Barb, for starting us off. So Barb mentions that computer science teaches critical thinking skills. which is really important regardless of what your students end up doing longer term. I really appreciate this transparency. Beth kind of says, like, this is something that I'm not necessarily strong in, but she's here because she knows it's important for her students. So very commendable. Thank you, Beth. Jessie works at ISB and is excited. Let me make sure I can read this. And is excited to see how to expand access to all students. Really appreciate Charles's idea, right? We want students to not just be consumers of technology, but be able to create. And how powerful is it to have that in your toolkit? We see there's new Illinois standards that have been rolled out. So how can those CS standards be incorporated into your school or district? Leah will definitely talk about some elementary tools and supports that we can provide later on in the deck. And then, yeah, there's a lot of piecemeal programs. So what does a more full pathway look like? We will see how much we can get to of some of the things that folks are excited to learn about, but I'm pretty sure we'll cover almost all of these. And really just excited to hear that y'all are here ultimately for the students, right? Like, you know that this is an important and it can be transformative skill for them. And again, I just really appreciate that y'all are here putting in the extra time to provide this access for them. So a lot of folks touched on these three things. I think especially Beth talking about the future, right? Three kind of really big reasons. And it's okay that students, families, communities, and you as a teacher might have one of these reasons rise to the top. And I think they're all equally valid. The first simply is just economic mobility. When we think about a lot of the students that we might work alongside, there's a huge opportunity for them to build generational wealth simply by getting one CS degree and one software engineering job. That truly can be transformative for students and their families. Computer science is a top paying degree. Jobs are growing at 3 times the national average. And a little later on, we'll talk about what those average salaries are here in the state of Illinois. So just point blank, it's a good career. The second thing I think which resonates with a lot of folks, and I think is really important to call out, is technology impacts and will continue to impact every part of our lives. So when we think about the owners of billion-dollar companies and the power that comes with that, we need to make sure that that power is distributed, that decision-making is distributed across the identities of the communities that we support. And then finally, a few of y'all mentioned this in the chat earlier, but when we think about, aside from computer science, just the transferable skills, computational thinking, computational literacy, these will be critical. Again, not just a nice to have, but a need to have for your students as they navigate their space in the world. So y'all are obviously here because you agree with some of these rationale, and we'll spend the rest of the time thinking about, well, how might we implement this in our own schools and districts? So at a high level, Illinois is probably in the middle of the pack when we think about computer science access for our students. So a little less than half of high schools offer computer science. As you might imagine, that access is concentrated to urban and specifically suburban schools, and then schools with lower percentage of students that qualify for free and reduced lunch. So there's definitely an equity and access kind of contingency there to make sure that it's one thing to say these high schools offer CS, but we also need to be interrogating which high schools they are and why that might be. When we think about equity, in addition to thinking about geography, the rural and urban gap, we can also think about race and gender. So due in large part to the incredible effort of Chicago Public Schools, who has made computer science a requirement and actually graduated their first graduating class with that requirement, Illinois has one of the most racially representative CS enrollment populations of any state, which is something as Illinoisans we can be very proud of. When we think about gender, so the gap between female and male students in computer science, there's a huge gap. About 38% of CS students are female. Obviously, to be at parity, that number would need to jump up to 50. And that number has grown a little bit, but there's still a lot of work to do there. As I mentioned at the top, economic mobility is a huge reason to think about access and exposure to computer science. There are 22,000 computing jobs available in our state every month, which is, to me, that's mind-blowing, 22,000 jobs available a month. And those jobs have an average salary of $84,000. And then when we look on the supply side, there's only 3,000 students graduating with CS degrees from our state. And so in terms of career outlook in our state, continues to be good. Of course, we want to think about where in the state your schools are and thinking about how you might engage with local software engineers, local computer science professionals to get a more nuanced version of the career outlook for your communities. So that was kind of just like a high level why CS and the state of CS in our state. We're going to spend the rest of today's session talking about actually implementing computer science. So just that we can all start to learn and understand from each other, curious what level of implementation, computer science implementation specifically, your school is engaged in. So you're going to type a number in and then add any additional context. So 1 is like none. Like you being here is like you're the champion of this work. 2, there's very early implementation, you're exploring CS options. 3, there might be 1 or 2 CS classes that have been implemented. And 4, there's a robust CS course list. So thank you for putting in that number and then any additional context, just so that we can learn from each other and where we are. All right, I see a lot of 2s. Thank you, Beth, Charles, Charity, and Frank. I appreciate the nuance, right? So Leah says like based on elementary versus high school, we might be further or closer along the scale. And it seems like Frank's in a similar situation. High schools are maybe at a more advanced place than elementary schools. Great. So I think this is helpful that most of us are kind of exploring CS options. I hope to share some CS options with y'all. And then for folks who are closer to those 3s, I'm excited and would invite y'all to share how the implementation has been going and any things that y'all have learned. So at the end, we'll have some time for that dialogue. I do appreciate what Beth said. I think a lot of times this type of work falls to like a tech coach or a tech teacher or a math teacher. And so thinking about how we're building that capacity is really important. So now that we know that most folks are kind of in that exploring stage, here's kind of 3 tips that I would offer. There are both regional and statewide computer science Teachers Association chapters. I'm from Chicago, so I know that there's a Chicago one, a Chicago suburbs one. There's also a Central and Southern Illinois chapter that's combined. And so, if you're one of the few and you feel like you're on an island, joining the CSTA alias and group will be really helpful as you think about implementation. Twitter, I know a lot of educators are on Twitter. This is especially true for computer science educators. I would definitely connect to folks on Twitter. And then finally, reach out to your district leadership and see if there's anyone else in the district that's even just in the exploratory stage, which can also be hard to find because if you're exploring, you wouldn't be formally listed anywhere. But finding a community of practice before you dive in, I think is a really important to building your foundation. The next thing, oftentimes y'all are amazing champions for your students. You want to do it all, but I would suggest starting small. So just put a +1 in the chat if you've heard of Computer Science Education Week, which happens every December. Okay, so a few folks. Awesome. So good. I'm actually surprised at so many people. Computer Science Education Week starts in this is a week in December, usually the first week, which is also good when you're thinking about winding down for the semester or for just before the winter holidays. You can start by just doing an hour of code activity during Computer Science Education Week, and there are so many nonprofits and companies, including Google, that have offerings. We'll bring someone into your classroom virtually and help walk your students through what might be their first, but hopefully not last experience. Or think about an after-school workshop. These are really important ways to think about exploring these things, testing, iterating before you commit to a full course. I would also offer, finally, don't invent the wheel. I'll show you some Google products later, but I highly recommend code.org in terms of free curricula that offers really great, not only instructional materials, but again, those communities of practice that are built in. And then also Khan Academy. So both of those platforms go from early elementary all the way through high school. So if you write down nothing else today, I would definitely write down code.org and Khan Academy. So it's one thing to talk about implementing CS. It's another thing to be really intentional about who the students are that are engaging in CS and what the outcomes are for those students. And so when we think about equity for any classroom spaces, for any learning experiences that we're designing, so this doesn't have to be specific to CS, but what are some ways that y'all think about designing for equity in your own classrooms? And it doesn't necessarily need to be a CS classroom. Thank you, Frank, for calling us out. Yes, bringing in BIPOC professionals, Black, Indigenous, and other folks of color as role models, right? A lot of times if students can't see it, they won't be it. And it is really critically important, especially for students who have been historically excluded from tech, to see role models in their classrooms and to have and build that social capital. Thank you, Frank. He also offers another suggestion, which is thinking about entrepreneurs, business owners that also identify as folks of color so that they can give a tour of their company, right? And again, provide that future forward lens for your students. As y'all are thinking about and excited about exploring computer science options, what are some ways you might think about equity as you're exploring those options? Go ahead and add some responses to the chat. Well, let's jump into a few things that kind of I've come along, both rooted in research and rooted in some of the practices in my own classrooms and in classrooms that I've seen across the country. Really like, though, Frank's additional response: listen to underserved populations and personalize the CS programs to their wants and needs. I think this is incredibly important, right? We want to be building with our students and building with communities, and not necessarily building for them. The difference there is a little nuance, but really making sure we're understanding and listening first, and then designing later. And I think the nice thing is that code.org is especially intentional about building culturally relevant pedagogy. And some of the Google programs that I'll share later are also really intentional about building culturally relevant pedagogy. And what that means is, how are we making sure students' own interests, identities, and experiences have a chance to be shared and celebrated as they're building meaningful projects, right? With computer science, you can build a whole slew of things, but we want to make sure that they're personally relevant and meaningful to these students, and that they're given a chance to have a voice in our classrooms. So I appreciate that, Frank. Thank you. So I'll list 3 ways that we both try and bake into the programs that we design here at Google, but also that are really rooted in research. And so one huge reason why we see a gender gap and a racial gap when we think about who goes on to become software engineers is just the narrative of computer science, right? So I don't know how many folks were around in the 80s. I certainly was, but when IBM first rolled out their computers, and you can actually Google this, Google like IBM like personal computer ad, and you'll see it's all these like young white men, young white boys, super nerdy glasses, maybe their dad's in the background, and they're working on their personal computers. And it was during that exact time in the 80s that, even though gender representation, the gap was closing, as soon as the personal computer got marketed to young boys, and specifically young white boys, there was a huge gap then in participation. And that also coincided with movies like Hackers in the 80s, that really kind of portray this idea that computer science is something that people do alone in the basement, and a very kind of like nerdy narrative. And I say that as a nerd myself. But we want to make sure we're reshaping the narrative so that folks aren't assuming they know what computer science is before they even had a chance to experience it. And if you talk to any of my colleagues at Google, they will tell you their jobs as software engineers is extremely collaborative. They probably spend 40% of their time working with others, either in meetings, doing design mock-ups, or doing pair programming and programming together. When we talk about how computer science is both collaborative and communal, we see that the participation rates for students from historically excluded groups actually jump up. The second intervention that has proven to be really successful is to be explicit about talking about stereotype threat and imposter syndrome. When I use that word imposter syndrome, if you've heard that before and have a quick definition, would love you to throw that in the chat. Does anyone know what imposter syndrome means? So imposter syndrome is a really helpful way to think about the feelings that a lot of us feel when we're getting involved in a space where A, folks might not look like us or share similar experiences, and B, we think that these places and spaces were not built for us. And so by naming like this idea that like, hey, a lot of people feel that like, I don't belong here, I'm not good enough to be a software engineer, I'm not good enough for computer science, you first name it and then challenge and say like, a lot of people feel like this and it's simply not true. And here are some ways to cope with it. Same thing with stereotype threat. Teaching students about this has shown to increase not only their persistence in it, but decrease GPA gaps between majority and minority students. Another thing I'd offer is to create spaces that normalize failure. Computer science is incredibly hard, but I tell my students, I expect you to get stuck. I expect you to break things. That's why you're going to get paid big bucks in the long run, because computer science is hard, and it's how we solve those problems and come out of that failure that make us successful. The last thing I'd offer for those of you thinking about starting a computer science program in your schools, there's a lot of research around recruiting female students in friend groups. Meaning, if Beth is starting a CS program at her school, she might ask one of her students, but in tandem with another one of her friends, to join the class together. Those relationships that especially female students have really help them persist in computer science, and is a great recruitment tool as you're thinking about who might be engaged in computer science classes. It's one thing to talk about building growth mindsets. It's another thing to just show you like 2 things you can implement in your classrooms tomorrow. So Jessica, I really appreciate that your video is on. Thank you. I can't quite see everyone's video, but I will still ask you to do this activity with me. So you're going to stick, thank you, Karen. You're going to stick one index finger out. Thank you, Charles. Thank you, Charity. You're going to stick one index finger out like this. And then you're going to stick on your opposite hand a thumb. Awesome. Charles is ready. Jessica's ready. Karen's ready. Okay. I'm going to ask you to do something you've never done before. Are you going to be good at it? No. Okay. So you've never done something before. You're not going to be good at it. All right. So one index finger, one thumb. When I say go, you are going to switch so that your opposite thumb and your opposite finger are out. Go. 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 I see people concentrating really hard. All right, you can put your hands down and you can turn your cameras back off if that's more comfortable for you. If you've never done something before, you're going to be bad at it. Yet for some reason, when we either start teaching CS ourselves, we're like, I should be good at this. Or for our students, when they start learning CS, they think, oh, I should be immediately good at this. The idea that learning comes in small pieces, and that at first you might have to think really hard about what you're doing, but I guarantee if you practice it a little bit more, you have to think about it a little less. And then at some point, you'll get really good at it. That's because your neural pathways haven't made that connection before, so you're not going to be great at it. But putting in a little bit of work will make you better. And the same thing is true for computer science. At first, you're going to be in a world where you've never done it before, and you're not going to be that great, and that's okay. The thing is, we keep practicing, and eventually we can do it. To really drive this point home, usually after I do that activity with my students, I'll show them this website. This person was not very good at computer science when they first started. Anyone have a guess at whose website this is? They're a tech entrepreneur. Yes. I like how we're not even putting his first name in there. Zuck. All right. So this purportedly, I don't know if this is true, but this purportedly is Mark Zuckerberg's first website. And depending on which computer science curricula you engage in, you might have some web development in there, you might not. But when I do teach students web development, I always show them this page because their websites usually look better than Mark Zuckerberg's first website. But what I say is that this web page starts very basic. You would never look at it and say, wow, this guy is going to have $1 billion company and have all of this impact. And so it's important for students to know that, like, when they first start, they might not be that good, but it's how they persist and how they keep growing and learning, and their projects will continue to evolve alongside their own growth. So a few of y'all said that you were in that early stage of exploring a few computer science options. I wanted to share a few additional resources in addition to the first two that I shared before. So I highly recommend code.org as I think the first place you would go. Khan would probably be your second place to go. And then if these specific tools seem to work for your context, I would also recommend taking a look at these. The first tool, these are going to be 3 Google tools. The first one is probably most well suited for folks in the classroom. And then I'll kind of talk about an additional program and an additional product. So CS First is built off of Scratch. Scratch is block-based coding that came out of Google technology, but that was leveraged by MIT to build a really robust community for students to learn how to code. What CS First does is integrates a curricula on top of the Scratch platform. And so there's no coding experience required for students or for teachers. It really covers a wide range of students from 4 to 8, 4 to 7, and it's been used by thousands of teachers and millions of students. So really well vetted in terms of integrating with your LMS, in terms of making sure you're understanding what projects students are working on and being able to provide feedback for them. Also, first for teachers that teach ELL students, there's translations available in Spanish, which helps this become a pretty accessible tool. The nice thing about CS First is that because it's a Google product, there were a lot of software engineers that worked on this in tandem with instructional designers and teachers. And so it's this really kind of robust and well-designed exposure opportunity for students. Frank mentioned earlier the importance of role models of color, role models across genders, and the instructional videos within CS First are kind of designed to make sure that students are seeing a wide representation of identities in the folks that are teaching them the course. Yeah, of course, Jessica, have a good one. And so, you know, that I think is a really important, especially if students are first getting exposed to CS. And then finally, as I talked about earlier, computer science is not one guy alone in a basement coding in his glasses. It's collaborative, it's exploring students' interests, it's talking about peer relationships, and the curricula that is baked into CS First really promotes all of those things. So in terms of teaching, what you would need to do if you wanted to teach CS First, you don't need any experience yourselves. You're a lead learner. There are kind of everything you need to just like get students set up and get started. So there's video tutorials that they'll work on. We just launched an in-code editor so they can get extra hints as they're coding. And then finally, it's completely free. However many students you want to enroll, however many activities you want to do with them. So that is CS First. I do want to pause and open the floor for questions about CS First, if there are any. One nice thing about CS First is that you don't have to commit to a full year or for a full semester. You can do, they're called different like themes. You can do one theme, see how you like it. A theme can last anywhere from 2 to 4 weeks. And so this is kind of a good way, like I said earlier, to start small. If you think of a question later, we will end with some time for questions. The next, how long are the lessons? Great question. I think there's not they're not time bound, right? So, and they're built to be flexible. So they would be between a 45-minute and 75-minute class period. Great question. Thank you, Charity. Keep those questions coming. I'll answer them as they come up. The next program is for folks on the call who are engaged with high school students. These next two are a little less like, here's something that you can use right away in your classroom, and more, here's something that your students can get introduced to as you continue exploring CS in school. Here are some ways that they might engage out of school. So CodeNext is specifically designed for Black, Latinx, and Native students. The idea of like, how can we create affinity spaces for these students to feel just as included, feel that sense of belonging, just like their peers might. And so we know that there's a lot of opportunity and a lot of incredible genius that exists in our communities, but there's a lot of obstacles that folks might face. And so CodeNext was really designed to help students navigate those obstacles. CodeNext really thinks about three things. Earlier on the call, Frank mentioned this idea of social capital. How are we introducing students to professionals in the space? That's probably one of the most important pieces that we can do for students, is build up their social capital. As grown folks, we know that it's not always what you know, it's who you know. And so CodeNext is an opportunity for students to work with industry professionals. Of course, skill building is important. We want to make sure students are developing the skills to build projects that they are personally proud of, but that they can also continue to build projects and impact in the technology space. And then finally, how are they building their own identity as a computer scientist? How are they cultivating leadership? And those are really the three themes that anchor the CodeNext program. If your students are interested, your high school students are interested in joining CodeNext, in the state of Illinois, we do not have an in-person lab yet, but students are welcome and should join CodeNext Connect, which is the virtual program. It is synchronous, so they still have real lessons with Googlers. It just is done virtually. If you would like more information, or you want to sign up for the CodeNext letter, those links are here. And maybe Karen or Anne could help me by posting those in the chat. What questions do y'all have about CodeNext? And again, this is more student facing, something that you could share with your students and they could kind of sign up for.
Are students guaranteed to get in to the Connect, or is it a wait list?
Yeah, great question, Frank. There is an application process. I'm not super familiar with what the criteria are there, but you never know unless you try, and so definitely encourage students to apply. With that said, there's no experience requirement. We're actually trying to look for students who have low exposure, high interest, because that's really the audience that we're trying to target. So I wouldn't say like the student has zero experience, they shouldn't apply to CodeNext. Those are actually the ideal folks to apply to CodeNext. Again, if we'll have time at the end for some questions, but want to move on to the third product. This is something that you can put in front of students, especially if your students don't have access to laptops at home. I think part of that access gap did close during the start of the pandemic, but a lot of students still only have a mobile phone. And so this is a tool that was specifically built to provide access to coding for students who mainly are on their phones. And so the product is called Grasshopper. So students can log into their phones. They learn real JavaScript. So even though it's phone and block-based coding, they're learning a technology that is used by millions of professional developers. And it really helps students kind of engage in the self-paced way of learning how to code. The really nice thing about Grasshopper in particular is that internally we've been able to do some research around increasing self-efficacy, this belief that students know that they can succeed, and even just something as simple as doing, 20 minutes on their bus ride home really helps them think about their own identities as computer scientists. That said, high performance students don't always recognize their talent, and I think that's a really cool way as teachers to talk about, like, hey, were you able to do any Grasshopper last night? How did it go? And kind of encourage them in that way. There are some teachers that use this in their classrooms, but I would say CS First is really the tool for that. And then this is kind of like a mobile supplement that students can kind of engage in coding practices once they're at home or on the bus ride home. So hopefully some of this was helpful, right? The idea of why CS is important, a few tips about how to implement CS, and then specifically how to design for equity. Would love, though, to take time to make sure that we're learning from each other as well. So if you have launched a CS program, big or small, at your school or district, would love to understand what suggestions folks have for others. Feel free to unmute yourself if talking is easier for you, or if you're more comfortable typing, you can type instead. Thank you, Frank, for kicking us off. Okay, so in Wisconsin, Frank looks like he's launching a new program using CS script. And Frank, can you talk to us a little bit more about, like, how did you decide on that platform, and like where are you at an implementation stage, and what do you wish you knew earlier?
Well, it's not a platform, it's a kind of a planning and goal setting for districts to kind of develop, kind of align their curriculum and curriculum map and try and figure out which of these tools they're going to use at which grade levels. And so they have a lot of partners with, Google and Scratch and different, code.org. And so what it's doing is trying to get districts, kind of like what this presentation was about, to see the value in having a longitudinal curriculum that doesn't just rely on teachers being the, grassroots type of momentum, but more or less bring a team to our office, or, and we'll sit down with this CS script, kind of curriculum and say, hey, how do we, what barriers are in place? What do you need, in order to get this, kind of like what Chicago Public Schools did, how are we going to make this, a district-wide or a system-wide movement, rather than just hope that teachers will pick up a free program and do a little bit on coding week.
Right. No, thank you. I just dropped the link into that. I hadn't heard of the script program, Frank, and that might be like one of the most valuable things of this entire time together. So thank you so much for sharing about that. And I do think you're right. I think for all of the teachers on this call, thank you so much for putting in this work, for putting in some energy to exploring options. And I really hope that as big corporations, as district leaders, like, we can partner together to make sure that you don't have to have this extra burden, that there's a district-wide plan that's maybe sponsored by companies to really make sure that your students are getting the support they need because you have the support you need. So Frank, thank you so much for talking a little bit about script. that seems like a really helpful resource for the teachers on the call to kind of bubble up to their administration. So thank you. Yeah, I appreciate this call out, Charity. So Charity's talking about they're a library media specialist in a junior high and talking to their counterpart in the high school, thinking about our students are so plugged in to social media. A lot of that's on their phones, A. And B, even if they are on their laptops, it's, you know, they're not necessarily exploring the whole suite of even computing skills, let alone coding skills. So I think one thing that I didn't mention here, because it's not computer science related, but computing adjacent, is Google also has an applied digital skills curriculum that is kind of like CS first in that it's designed for teachers to pick up and directly teach. And I'll drop that link in the chat as well. So there's kind of two phases, right? How are we getting students used to navigating a computer and kind of like the basic suite of applications? And then how are we thinking about computer science? Thank you, Charity and Frank, for sharing a little bit more about your experience. I do want to give time for one more person to talk about, like, especially if you said you were in that 2 stage, what have you been exploring? What last questions do you have that we can kind of brainstorm amongst the group? Because I guarantee if you have a challenge, someone else has had that challenge, now's a really good time to explore it together. All right, bye, Charles. Have a great class. As y'all continue to explore, please don't do it alone. Join your local CSTA chapter. Get involved on Twitter Ed Chats. I really liked Frank's suggestion about like offering script training or resources for your district. And I appreciate it. Seems like Beth has a challenge that she's facing. She's done an hour of code week with her students, but not sure what the best next step is. And Beth, for a little bit of context, what age ranges do you teach? Six through 8. So yeah, I would say like the next step between like an hour of code is maybe a week or 2 or 3 weeks of code, right? And so I would explore the code.org curriculum. I would explore the CS First curriculum, see or talk to other teachers if they've kind of compared and contrasted. Both of those are free. Both of those offer instructional supports. Does one seem easier to implement? And just try a 2 or 3 week unit with your students as kind of the next step. Charity has a question about pushing these types of opportunities into core curriculum to enhance learning. I think this is a really great question. Luckily, I think both Code.org and CS First have explored this before. So if you just kind of Google search your subject plus CS or plus Scratch or plus Code.org, there are lessons specifically tailored across all the disciplines, right? Math, science, social studies, and literature. And so the CS Plus movement is really taking off at every level. It just might require a little bit of digging through resources, but nothing that a Google search can't resolve for you. Yeah, so like social studies plus Scratch, you'll see a lot of results come up. And I'm glad Code.org was a success. Yeah, they're big partners. We are big partners of them. They're big partners of us. And I definitely used them when I was an 8th grade teacher myself. All right. Again, y'all should be incredibly proud of being here for your students, right? It's an extra hour at what you could be doing your prep or your lunch. And so the fact that you're here learning more, contributing to your skills, I just like really commend you, and your students are lucky to have you.